Hello everyone, welcome to today's math challenge. Look at the question before us here. Solve for x in 1 to the power of x equal to 3. Wow. So what number can we raise 1 to give us 3? Can we get a real solution from this math problem? I don't think it's possible. So our answer is going to fall in the imaginary world of mathematics. So, but how do we solve for these imaginary roots here now? So let's take the first thing here, which is solution. We have this question here, which is our 1, okay? 1 to the power of x equal to 3. Now, with this, we just have to remember or recall what we call the Euler equation, which says that if we have your, it says that your e to the power of pi I plus 1 equal to 0. If we send 0 to this side, it's going to give us our e to the power of I, then this is equal to minus 1. But what we have here is positive 1. So all we just need to do is to raise both sides of this expression to 2k, right? So it's going to give us our e to the power of pi I all raised to 2k, where k is a set of constants, then equal to minus 1 all raised to 2k also. Now, according to the law of indices, it says that if you have your a to the power of m bracket your your n, this is equal to your a to the power of your mn, then if we want to consider this, we can separate these two quantities here. So this is going to give us our e all to the power of pi I, then all raised to the power of 2k. This is equal to our minus 1 all raised to the power of 2, or in square bracket raised to the power of k. So what is minus 1 to the power of 2? That will give us positive 1. And so this is going to give us our e to the power of pi I all raised to the power of 2k. This is equal to our 1 to the power of k. And what is 1 to the power of k? 1 to the power of a number we've said this is a set of constants that will still give us 1. So in other words, we can use this to multiply this, and this will give us 1. So this will now give us e to the power of our 2k pi I is equal to 1. Now look at this expression we have in here now. We have 1 here, right? So with this one we have in here now, we can come to our equation and replace it here. So we said 1 is equals to this quantity here. So we can come in and replace that here. So this is going to give us, or this now implies that our e all to the power of 2k pi I all raised to the power of x is equal to our 3. Wow. So if we use this to multiply this according to this law here, so we're going to have this to be our e to the power of 2x k pi I is equal to 3. Wow. What do we do here? Now, we want to eliminate both sides of the equation so that we can eliminate this e here. So we will bring in ln this e times our e to the power of 2x k pi I equals to the ln of our 3. Let's put this in bracket first. All right. Now with what we have here, what happened? This will go with this. So we're now left with 2x k pi I equals to the ln of R3. Easy. What are we looking for? We are asked to solve for x here, right? So how do we get this x here now? We divide by this other quantity apart from x. So let's divide through by 2k pi I, and here by 2k pi I. If we do this, what happens? These two will go with this, k will go with k, pi I will go with pi I. So we're now left with our x now be equal to ln of our 3 all over our 2k pi I. We want to remove or eliminate this I that is at the denominator. We want to take it to the numerator. And how do we do that? We multiply everything there by 1. So if we multiply this by 1, and we decide to bring this as our I all over I, that will still give us 1. And so we can rewrite this part of it as our ln of 3 all over our 2k pi I times our I all over I again. If we use this I to times this I, that will give us I to the power of 2. We all know that, right? Good. So what is I to the power of 2? Now, from the relationship, we know, first of all, let's write this out. This will now give us here ln of our bracket 3 close bracket all over our 2k pi I square. And meanwhile, we have our I here also. So we record the relationship. We see that the square root of minus 1 is equal to our I, which is imaginary, right? So from here, if we decide to square both sides, this will leave. So we have minus 1 is equal to I square. And here we have I square. So we can rewrite this as our ln of 3I all over our 2k pi times minus 1, right? Good. So if we use this to multiply this, it comes to this side like this, and of which we can rewrite this. So we can now say, therefore, our x is equal to minus ln of our 3I all over 2k pi. We say where k is a set of constants ranging from 0, 1, 2, 3 to infinity, right? So in this solution, we have infinite solution to the value of x here. All right, so this is the final value of x that will actually satisfy this unusual equation 1 to the power of x equal to 3. So this brings us to the end of this math class. If you learned something from this video tutorial, give the video a thumbs up. And do not forget to share this wonderful, this amazing trick with other people who need this math knowledge. Thanks for being there. Thanks for watching Math Prowess. Keep watching Math Prowess until we see you in our next video. Bye.